This video is going to review square root and cube root graphs, which was section 7.5 in our book, probably the easiest section in chapter 7. We went through it kind of quickly, but I want to make sure you're comfortable, whether it's a square root or a cube root graph, discussing the shift that takes place with the graph and also being able to identify the domain and range of each. So that's what we're going to go through here. We're going to go through 4 examples. We'll do 2 square roots and 2 cube roots so you get a chance to see everything that could happen with these. So what we're doing here is we're looking at a couple square root graphs. We're going to draw a rough sketch of it, and you can use your calculator to verify if you need to, and then talk about the shifting that happens with the graph based on your basic just square root of x graph, and then write the domain and range. So for the first one, we have 5 times the square root of x minus 3 plus 4. So the first thing that I want to do is I want to write down what shifting is happening. So this one, because you have a minus 3 under the radical, this is going to go to the right 3. Because you have a 4 on the outside, it's going to move up 4. When I go to graph it, I'm going to go on my graph, and I'm going to move to the right 3 and move up 4 and put a point, kind of the starting point of the square root graph. Because it has a positive number in front of the square root, it's going to arch up. And that is the main part of my graph. Now with domain and range, your domain are your x values. So this x value is starting at 3. That's the first number you can put in, and then any number bigger than that. There's a lot of ways to write that. You can write it x greater than or equal to 3. You can also write it in a notation where you go from 3 to infinity. For my range is starting at a height of 4 and then continuing to go up. So one way to write that is y is greater than or equal to 4. The other way to write that is going from 4 to infinity. For the second one, we have negative 2 radical x plus 3 minus 5. So first thing, I'm going to talk about what's happening compared to the basic square root of x graph. First of all, this negative right here will flip my graph. The plus 3 is going to move us left 3, and the minus 5 is going to move down 5. So when I go on my graph, I'm going to go left 3 from the origin and then down 5. Right about here. But this time, be careful when you draw it, you're actually going to be arching downwards. That negative flips it upside down. My domain is going to start at negative 3, so it's going to be x is greater than or equal to negative 3, or you can write it as negative 3 to infinity. My range is a little different than the last one because my range is actually never going higher than a height of negative 5. So we're going to write it as y is less than or equal to negative 5, or we can write it as negative infinity up to negative 5. Whenever you have that negative value in front of your radical, your range will actually be getting smaller. It's going to be less than or equal to whatever number, the height that it starts at. The second piece is looking at cube root graphs. Cube root graphs are the easier of the 2 graphs because cube root graphs are continuous. You don't have that kind of origination point where it continues going, so your domain and range are very simple. You still have the same shifting though. So for example, for this one is going to shift right 3 and up 1. So we're going to go right 3 and up 1. And we think of this almost like a snake type graph. It's going to come up through that point and then continue going. My domain and my range for this one will be all real numbers. The other option is you could write from negative infinity to infinity, but in this case all real numbers is probably a little easier to write. And then the last cube root graph, this one is going to flip. So if you're asked to just give a descriptive point of what's happening with this, it's going to go left 2, and it's going to go down 3. So let's go left 2, down 3, so right around here. But this time when it kind of snakes through, it starts up and comes through and down because that flipping. So the idea that it kind of, instead of starts below and comes up through that point, it's going to start above and go down through that point. My domain and range, however, do not change. Any cube root graph will have a domain and a range of all real numbers because you can put any number into a cube root and you can get any answer out of a cube root. It goes forever left, right, up, and down. So this goes through everything that you're going to be asked to do from 7.5 when you take a test. Basically, you should be able to describe the change of the square root of cube root graph in either words or using numbers. You should be able to graph a square root of cube root graph, and you should be able to give a domain and a range of any square root and cube root graph.